Hey guys, we're going to continue from where we left off last time, and we're going to talk about equations of lines, okay? And we're going to use the same example from, the same example from last time, where we talked about slope. We're going to tie it in with equations of lines, okay? So, last time we found our slope to be 2, okay? We calculated it and found that the slope of this line is 2. That means if you go from any point to any other point, then you're going to have a rise of 2 over a run of 1, that proportion, okay? The most popular equations of line is what they call the slope-intercept equation. And it's y equals mx plus b. Okay, and I'm going to dive right on in here without going over too much right now. We're going to work this problem and then we're going to discuss it, okay? So bear with me. All right, in this case, x and y represent the points along a line, okay? So this is x coordinate, this is the y coordinate, okay? M is, guess what? The slope. And B is what we call the y-intercept. That is the y coordinate where the line crosses the y-axis, okay? So in this case, do we have a point that crosses or is on, rather, the y-axis? We do. We have a point here, 0, 3. And notice the x-coordinate is 0, but the y-coordinate is what? 3. So guess what our y-intercept is? 3. Okay? So that's a given. All right. Now, m, we said, is our slope. So our slope value is 2. And for an equation here, we need the variable y and the variable x. So in a situation like this right here, sometimes you're given a test and they expect you to know what stuff is and how to use those different equations. This right here is that's a nice way to dive right on in, get your answer, and go to the next problem. Okay, the equation of a line, or equations of lines, they are derived from the slope, or the slope formula, okay? You're like, what? Yeah, okay. It all ties in, it's all related. So when you figure out those relationships and think things through, a lot of times it can be a lot easier to work the problem. So let's go back and recall the equation of a slope. We just need a bare minimum of 2 points. Okay? We have x1, y1, x2, y2. Okay? Rise over run, that'll give us the mathematical equation of slope. Okay, so we understand it both physically and mathematically now, right? Okay, so let's tie this in to the different equations of lines. And so I'm going to try to hit on, I think three of them at least. Okay? Now, let's rearrange this equation, and I'm kind of going to skip some steps as far as the procedure of math. And if you need help with that, go to my website, www.declaremath.com. Okay, declaremath.com, and look at my free online book. Okay, you can see my book for free. All right, and I go through how to understand math and how to work algebra, over basic arithmetic, like carrying, borrowing, etc., and algebra in order to work the higher level problems. Okay, so I kind of accidentally ended up putting the book together because I as being an engineer, I was able to teach geometry with no problems, but a lot of times the kids did not know how to do the geometry because they didn't have a strong grasp of arithmetic and algebra. So we would always do a review, and then in order to bring them up to speed. So you got to know how to do algebra in order to know how to do geometry. All right? So go take a look at my book, okay? All right. So let's rearrange this equation here. We're going to multiply both sides by the denominator there, and we're going to end up with, probably didn't give myself enough room. Okay. If we multiply both sides by this denominator, we end up being able to write out the equation like so. Okay, and this here can represent any point. Okay, so we already have a point on there. We call it point 1. We said earlier we could have point 2, point 3, point 4, and so we represent that by just x and y. So we have the equation y minus, I made that ugly, right? Y minus y1 equals the slope times quantity x minus x1. Sometimes they go ahead and call this 0 here, same thing. This is known as the point slope form. I'm abbreviating there. Okay, point slope form. That's the point slope form. That's how they derive that equation from, or where it comes from. It comes from the slope directly, okay? Not magic.